Here, today let us start from the steam turbine, which we have already discussed in the last class. The steam turbine is a prime mover which converts the energy of steam into high pressure, energy of energy of steam into high pressure. What is prime mover? I have discussed. The prime mover is a certain machinery which convert the natural energy into useful energy to the people itself. The turbine is such type of prime mover which converts the heat energy, or sometimes it is also for hydraulic power plant. It converts the energy of the oil, energy of the water into useful electrical energy of the humankind, human race. So this is the definition of prime mover itself. Now, what you are doing in the steam generation system is the high pressure steam, it is supplied by a steam generator into a shaft work. What we want exactly? A shaft work which is good enough to run our alternator, or is it steam power generator, it profitably and quickly. এখন how we are getting it? The steam uh, will feed the high pressure. Then what we do, supplied by a steam generator into a shaft work, then, and it is then it becomes reduced, temperature is reduced, and it is exhausted to the condenser itself. The steam is being the energy of high pressure steam. What we are doing here, the high pressure, high temperature steam is converted into low temperature steam exhausted into the condenser itself. This is the job of a steam temperature. This input is high temperature and high pressure, and it is exhausted in the compressor with low pressure and low temperature itself. This energy conversion essentially follows in how will you do it? Essentially, you are following it two steps. First, the high pressure temperature farm steam. High pressure and high temperature steam generated in the boiler first expand in the nozzle and then comes out at high velocity and high temperature but low pressure. At the pressure is reduced to high velocity, but temperature remains more or less same. This high velocity of steam carried out from the nozzle coming out of the nozzle is will impinge on the blade mountation wheel. A wheel is carrying a number of blades of specific number and specific orientation and specific profile, and over which this high velocity steam will be impinged, and this blade will deflect by an angle, and it will suffer a loss of momentum of the impinged stream current, which is absorbed by the converted into rotating wheel in producing torques at the output of the wheel. So what we are doing, we are receiving in the condenser in the turbine the high temperature and high pressure steam, and passes it through a nozzle which converts the high pressure and high temperature steam into low pressure and high temperature steam with increase in high velocity, which is coming out with high velocity. So high pressure is being converted to high velocity, and as a result, pressure is reduced but velocity is reduced. High velocity, what we are doing, we are impinging over the turbine blades one after another. Turbine blades have specific orientation, specific size, and specific profile, which prevents the movement of the steam in high velocity and thus absorbing its momentum and creates a momentum by itself by its causing is the rotation of the flywheel itself. The all these blades are situated at the periphery of a shaft, periphery of a wheel, and they have a specific independent specific angle which is supposed to be faced by, with which it is supposed to face the steam jet and absorb the energy of the steam jet, at high velocity into the one and into the momentum at which is into a uh, into a loss of momentum, which is this loss of momentum the steam will absorb by the rotating wheel one after another, rotating wheel, which over which the plate is fixed and blade is being impinged. Uh, um, Blade is being impinged by the high velocity of high velocity steam pressure one after another, which causes the torque or in causes rotation in the causes, which means it causes the rotation of the wheel of the turbine itself. Now, there is a definition, a classification of turbine, which has a it's a specific classification of turbine, which is converted, which has turbine is not only is basically an assembly of nozzles and blades. What is we have the turbine? It is an assembly of nozzles. There is not a single nozzle kept in the turbine itself, and a multiple of nozzles which impinging high velocity steam over a multiple of blade, which is being mounted over a wheel of the turbine, and this pressure velocity energy of the steam is being converted is velocity energy or the momentum of the jet is being transferred to the blade, which in turn starts rotating the turbine blade itself. Now, the steam turbine are not only employed to operate the selected generation, not only generated to electrical and uh, to electrical generation for thermal and as well as power plant, a nuclear power plant to produce electricity, they can also be used. What you do is the large ship, ocean liners, submarines, and so on, which means they are creating the rotation of the blade of the rotation of the propeller of the machines as well as turbine itself by means of impinging the on the blades of the steam blades of the turbine wheel mounted there. Here, that is, they are not producing a power like large compressors, the power, but they can run power absorbing machines like large compressors, large blowers, fans, and pumps. So you can use the steam jet without using electricity run large compressors, large blowers, large fans, and pumps itself without where you are not having electricity for that. So all these compressors, blowers, fans can be driven by the steam power generation and by means of steam power turbine. Turbine can be generally uh, turbine can be condensing or non-condensing, depending on whether the back pressure is below or equal to the atmospheric pressure. If the back pressure means the pressure at the outlet of the turbine is below that of the atmospheric pressure, then it will supposed to be converted into a water itself. But if it is above the fluid, if it is above that atmospheric pressure, then it will remains more or less in the remains more or less in the condensing side itself. Actually, what happens here, for a small unit with reheat, you see, the steam turbine may consist of a single turbine when the electricity is expands through the turbine exhaust itself. Stop share. এটা তো দরকার নেই আমি আমার share screen. Hmm. Now what we have here, uh, without reheat, the steam turbine may consist of a single turbine. When the steam is, there is not, we are not reheating the steam. Steam enters the turbine here, converted converted this his velocity into the steam work, which in turns created torque on the output, and the steam is went out to the condenser itself. Actually, this is a simple process of turbine, oversimplified process of turbine. This is just called straight flow turbine, as in this figure, as well as in this figure itself. Here, premium comes directly, impinges over the blade of the shafts, and which is shown like this, and then outlet go out for the condenser line itself. But this is for a low for a low capacity unit, especially for the domestic purpose, or like this. Now, the steam may expand for the large section within unit without the reheat itself. Steam will expand through the initial section, then exhaust to the other turbine. But it happens for the last separate unit, there are different stories. Let us go through that. Now, here what you see here, there's the steam with two section condensing. What is going on here? The pressure is being coming here. The vapor is coming here through here, and it comes inside the now vapor comes inside here through a header. It goes to the high pressure turbine itself, and from here there is going out through a crossbar to go to the low pressure turbine, and it comes out comes out and goes to the compressor itself. HP is written as the high pressure turbine, and LP is the single flow low pressure turbine itself. Here one high pressure, one low pressure turbine is used, and crossover is a piping arrangement here which carries this condensed steam with high pressure to the from the outlet of the high pressure turbine to the inlet of the low pressure turbine. It's just helping the steam to pass from here to here, which again injecting over the low pressure turbine, and here comes out to the condenser itself. For single reheat cycle, it is not, there is no reheat cycle itself. Uh, Now, for a single reheat cycle, the steam itself from the boiler flows to the high pressure turbine. This is the reheat. This is defined, shows that reheat cycle itself, where steam from the boiler comes through this header here, goes to the high pressure turbine, go to the high pressure turbine, and then here you one I mean, it extruded to a certain extent, expanded to a certain extent, and then go to the reheater, and then go to the reheater, and then from the reheater again reheated, this temperature is raised and then goes through another nozzle. It comes to the in, intermediate pressure or IP, and from IP it goes down to the crossbar itself. It goes out again. This temperature is reduced, but there is no more heat reheater is there, and through here crossbar it is sent to the low pressure turbine, and from it is converted into the power in the low pressure turbine, and it comes out to the condenser itself. Here what we have: high pressure, intermediate pressure, or low pressure. This is the low pressure LP, IP, HP, IP, and we have a reheater. So from the boiler, the steam comes in the high pressure. From the outlet of the high pressure, we are converting some of the pressure to the steam, come of the pressure into the work, then goes to the reheater, again reheated, then goes to the from reheater go through nozzle, again heated and high pressure and temperature. Again, it goes to intermediate pressure, and from the outlet of the intermediate pressure is going into a crossbar, means a piping device, which goes to the uh, low pressure turbine, which converted the remaining pressure and converted the remaining energy of velocity into low pressure, then goes to the compressor itself. But here we are having double for low pressure. There is one condenser turbine here, there is another turbine here. So two low pressure, one intermediate pressure, one high pressure, and one reheater along with a crossover is required for a single reheat cycle here. Next comes next what it comes, the double reheat cycle itself, where steam is coming in from the high pressure, side, went into the low pressure side, and went into high pressure, coming in from the high pressure side, and convert some of its energy and goes out with low temperature and pressure. Then again it goes to the high temperature here. If they reheated here, its temperature raised again, and then high temperature speed with comparatively low pressure, it goes through the nozzle system, and where that heat energy is converted into is full working intermediate pressure. Then again there is another reheat cycles, where the reheater skill goes back to the compressor itself. Again, another set of condenser, I mean the turbine itself, where it is goes inside, where the steam is heated twice. Four turbine mesh section is there: high pressure, low pressure reheat section, and double flow turbine section. Here, from the reheat section, it is went the crossover to the low pressure turbine, where it has not exactly two, but it is one, but there's two turbines are operating, and all these set of turbines are operating over a single shaft itself. Thus, we are having a single triple flow, floor flow. That is, we have a double flow. Here we may have a triple flow turbine, fourth flow turbine, and a sixth flow turbine, eighth flow turbine. Here, a triple flow designations indicates the use of the one double flow LP turbine and low and one single flow turbine itself. Here, what we show with the triple flow here is one double flow and one double flow LP turbine. Here is one in here, and one double flow LP turbine. One is here, one is here, and and a single flow LP turbine here, which means Flow depends on the number of flow. Here we are getting a single flow here from the high pressure turbine itself. High pressure turbine, after the converting some of the work, goes to the heater and again flow to the indicator pressure. Here one flow and then again single flow to the second pressure. So two flow turbine is there, and there is it is goes out from here, and the part of it goes to the second intermediate layer, and another part is go through the convert to the final low pressure turbine, where from here it is goes to the condenser itself. So a portion of the a full portion of the vapor is being used in high pressure turbine. Then from heater to go to the low pressure turbine, and from low intermediate pressure turbine. From intermediate pressure turbine goes to the single low pressure. From part of it is goes to the second intermediate pressure, and another part is go to the low pressure turbine through crossover itself. And both the outlets from second single flow low pressure to and double flow low pressure is from goes to the condenser itself. Turbines can also be designed by the type of extraction involved in any. The stream exerted for the turbine itself. The turbine is designated by the type of extraction involved, if any. The steam extracted for feed water heating varies in pressure and flow as a function of load. The stream is coming out for heat water heating. The amount of feed water which is being feeded, what is feed water? The amount of water which is being fed to the boiler for reheating, because the from the condenser itself, or also from some additional water may be also be required, because full 100% water cannot be recovered. Then we part of it out of the same extracted is used for reheating purposes, and so as reheating process, so that our coal consumption is comparatively reduced and flow as a function of the load itself. And this also according to the load requirement of the load itself. This variation is actually not, so no effort is made to regulate the pressure, which is called uncontrolled simple non-automatic. Uncontrolled simple non-automatic lever extraction, as in figure H itself. Here it is going on from high pressure to low pressure, and high pressure to low pressure directly, and there is no low pressure turbine is used, and directly goes to the condenser itself, which is used as use this temperature to increase the temperature of the flow water to a certain feed water which is already liquid in the condenser itself. And triple flow, the turbine is triple. Turbine simply supplying steam for process application must also supply steam with constant pressure. For increasing the feed water, we don't need any much control over it. You can go to any pressure and temperature. But if you use the outlet of the turbine as some other process, you have to use suitable set of valve to control the pressure for your own use itself. This type of this called triple control automatic extension turbine. Here, this is the triple automatic extension turbine. Here, the outlet from the condenser is controlled by means of suitable valve, so that it can go to the condenser itself. It goes to the condenser itself. The overall steam turbine generator is arrangement of a power plant is designated as tandem compound. The overall steam temperature generator arrangement of a power plant is designated as tandem compound or cross compound on the basis of shaft orientation. It is called tandem compound, means on the same shaft, all high pressure, intermediate pressure, double flow, low pressure, double flow, another double flow low pressure with the crossover. This is all operating there. Here, so all these pressures, all these shafts are operating at the same speed. The cross count compound arrangement typically consists of high pressure and intermediate pressure turbine operates at 3600 rpm itself. For the frequency of for the frequency of 60 hertz, uh, at 36 rpm, and this type of turbine operates at 36 rpm and for frequency of 60 hertz and a bipolar generator itself. Now, this RPM generally records in 36 RPM in USA, while India is required 50 Hz frequency and with 3000 driving generator. The LP turbine operates at the low pressure turbine operates at comparatively lower speed, but they are not working on the same shaft itself. Thus, low pressure turbine operates at lower speed and thus allows the use of single uh, the low pressure turbine lower speed allows the use of longer last. What happens here? Due to the low pressure compared to a low pressure turbine, the blades will be blade life will increase to a certain extent, and to its expansion to high pressure percentage, and thus uh, less exhaust losses, exhausting in higher turbine efficiencies. So, as we are running the turbine in lower speed, so we have to operate the jet in a comparatively lower speed. So, blades are comparatively has higher life, where and resulting in higher turbine efficiency, but less crossover of compounds units in the 1300 megawatt range with both shaft orientation operating at 30,000 rpm have been built. The dual shaft arrangement is used to minimize shaft length and any single generator side. What happens to the power plant? The steam generator turbine are thus typically designated by shaft orientation 25. The overall steam turbine generator arrangement of power plant is designated as tandem compound or cross compound on the basis of shaft orientation. The tandem compound unit has all turbines. The tandem operated unit has all turbines generated in line, connected on the same shaft, thus operate at the same speed. A cross compound typically consists of high pressure, low pressure, and at 3600 rpm, high pressure and low pressure for frequency of 60 hertz, and a bipolar generator rpm is equal to 36 rpm. But as in USA, but while in India 50 hertz frequency is required, this is equal to 3000 rpm. Driving a generator, the low pressure turbine operates at slower speed, allows the use of longer last stage turbine blades with expansion to high moisture percentage and less exhaust losses, resulting in very high larger turbine efficiencies and large cross compound units in the 1300 megawatt range with both shaft and orientations operating at the 3600 rpm. Having been building the dual shaft arrangement are used to minimize the shaft length and the single generator size itself. The power plant single generator supply, the power plant steam generator is thus typically designated by shaft orientation. So it is totally designated or differentiated by the shaft orientation itself. The number of low pressure steam falls paths and the last stage blade length of the low pressure turbine. What is this number of low pressure steam and steam flow path? Number of low pressure steam flow path called how many low pressure turbine you are using, and the last stage blade single blade length of the low pressure turbine. What is the single blade length? A turbine is registered TCF TC4F30 means indicates a unit that is tandem compound TC tandem compound having two double flow 4F two double flow 4F LP turbines and 30 inches. 30 inches is equal to 76.2 centimeter last blade length single blade length. A CC2F23 indicates a unit that is cross compound, that is CC, having one double flow 2F LP turbine with 23 inches or 28.4 centimeter last stage double length. CC means there is a cross compound for CC, one double flow, that is two flow, one double flow means two flow turbine, and with 23 means inches means 58.4 last length blood length. Now let us go through, this is for the turbine for the time being, and let us go to the power generation flow through the nozzle itself. What is the flow through nozzles? First, we have to know what is the definition of the nozzle itself. A nozzle is a duct by flowing through the velocity of a fluid increases at the expansion of pressure drop. A duct which decreases the velocity of fluid and causes a corresponding increase in pressure called difference called a diffuser. So what is this? It's a duct, means a passage made by say maybe ferrous, maybe non-ferrous materials of limited thickness. You can flow through the velocity of the fluid. By flowing through the velocity of the fluid, then increases at the expense of pressure drop. A duct which decreases the velocity of fluid and causes a corresponding rise in pressure is called diffuser. So there are two names. One is nozzles, where velocity of the fluid increases with the loss of pressure, where velocity of fluid decreases with the loss of pressure, with the increase in pressure is called diffuser. The same duct may either a nozzle may have either a nozzle diffuser depending on the end condition across it. If the cross section of the duct decreases continuously from inlet and to exist the duct is sent to divergent. To exist, the duct is sent to divergent if the cross section of the duct is initially increases, then increases, the duct is called convergent or divergent. Or initially it is divergent convergent. The minimum cross section of the duct is called throat. A load is thus fluid is said to be compressible if its density changes with the change of pressure or temperature. And if the density does not changes or changes very little, but fluid is said to be incompressible. You know, thus goes the vapor. Gases and vapors are compressible, whereas and liquids are incompressible itself. Thus, up to this moment, I am finishing the lecture because none of you are present. And next day, I will go for the more details of the nozzle itself from tomorrow morning. And